Continuing on, we are at number 8, where they are asking you to use the Euclidean algorithm to find the greatest common divisor of 2,433. This is also called the greatest common factor. Apparently this is used a lot in programming. I'm not a real big programming guy, so it's one of those things that you should know how to do. There are other ways of finding greatest common factors. I'll run through one at the end. It's pretty fast and convenient, but in the world of programming, this is an algorithmic process. That means it has value for those who work with computers and software. Anyway, what it involves taking the two numbers. Obviously, you can swap the order of them. So you put the big one first, 2,000. And you want to write it as 433 multiplied, multiplied by some integer value plus the remainder. Because that's just sort of a thing. This is going back to the modulus arithmetic from the previous one. So if I did this, if I did it the old-fashioned way, 2,000 divided by 433, I'd say this is going to go 4 times. 4 times that is 1,600, 1,732. If I then do my subtraction, I'm going to get 268. So 433 does not go into that. So this is where I'd say, decimal point, and I would start working on my decimals, but we don't want that. We just want to say remainder is 268. So I'd say 2,000 equals 433 multiplied by 4 plus the 268 for the remainder. What the Euclidean algorithm is, it tells us for the next step, we want to use this. It would have been the divisor from the first one. So 433 goes over here. And we sort of repeat the process by basically linking up the divisor and the remainder from each step and making them the two numbers that we're using for the next one. So I want to use the 433 and the 268. And it's pretty easy to look at this and say that's only going to go 1 time. So I'd have to ask what the remainder is. And the remainder is whatever we get when we subtract these two at this stage. So what are we going to have? 132, 165. And we would just continue that process. Eventually, because I worked this out earlier, eventually we're going to have a 41 and a 21. I'm just going to give it a dot, dot, dot. Eventually, if I did all the steps, I'd end up with a 41 and a 21. The remainder would have been 21 from the previous one. The divisor would have been 41. I'd sort of repeat the process. I'd say this thing there, I would do it again with the 21. Because we're going to do this, and the 20, we're going to do this until we get a remainder of 0. So 21 divided by 20, well, there would have been a remainder of 1. I'm going to take the 20. The remainder was 1. Oh, we got the remainder of 0. Once you get the 0, you look back to the previous step, and that last remainder you have, that's what the greatest common divisor of these first two numbers is. So if I do this, I do it until I get down to a 0, and then I sort of back up 1 step, and I get that last remainder. And that's what the Euclidean algorithm does. Anyway, this question they actually give you, which I should have changed the numbers on, but I didn't. It asked for the 3rd step, I think. 3rd step of the algorithm. Probably going to write this as first, second. Oh, I stopped right before the one I needed. So if we do this, we would have needed the next step. The next step would have been using the 268 and the 165. If I did 268 divided by 165, it would clearly just go 1 time, and there would be a remainder, and that remainder would have been 103. So hopefully, that's what they're referring to by the 3rd step. Should have changed the numbers for that one. I might redo this video and change numbers. Probably not going to right now, but we would get that. So that was answer choice D. So anyway, Euclidean algorithm is fairly simple and straightforward. Hopefully you won't be struggling with that one, and hopefully that's good enough. So anyway, there you go. That was number 8. For number 9, let me write that down again, 4:30, put it